Welcome to the 10th lecture on computational mathematics with Sage Math. In this lecture, we shall look at plotting graphs in Python. We will be looking at briefly because exhaustive plot of 2-dimensional and 3-dimensional objects we shall look at in Sage Math. So, first of all, let us see how does one plot graphs in Python. Plotting graphs in Python is done through a module known as matplotlib, which is a comprehensive library for creating static, interactive and animated graphics in Python. One can use pyplot and pylab modules inside matplotlib to plot graphs of various objects inside Python. Pylab actually is a combination of pyplot functionality and numpy functionality in a single namespace. We will be using pyplot mostly. So, let us look at first how to start plotting set of points in Python, what we call as scattered plot. So, first of all, let us import numpy and also import pyplotlib. From that pyplot as plt. Okay. So, we are importing pyplot from matplotlib and we are naming it as plt. So, let us run this. Next, in order to plot set of points, let us generate random 200 points which are normally distributed with mean 10 and standard deviation 5. So, both x and y are 200 random points which are normally distributed with mean 10 and standard deviation 5, and that can be obtained from random library inside numpy and use normal function. Okay. Now, this percentage matplotlib space inline, what it does is that it will plot the graphs inside this window itself. Of course, this is more useful when you use the IPython from command line, okay, because in that case plotting may be outside your editor. Okay. So, after you have created x and y scattered 200 points, then we shall use inside pyplot there is a function called scatter. So, simply say scatter x comma y and then ask plt to be shown, that is plt dot show. So, let me run this. When you run this, you get output which is 200 random points which are normally distributed with mean 10 and standard deviation 5. If you want to increase the number of points, you can simply increase this 200 to 500 or 1000 and so on. So, here what is it doing? It is taking set of points x I y I, where x is coming from this array and y is coming from this array, right. Now, suppose you want to change various things of this plot. For example, you want to make this color, let us say red, you want to give title to x axis, title to y axis, you can also give title to this graph. So, all these things can be done very easily. Let us see some of it. So, for example, if you want to change the color, you can simply say C equal to single quote R, this is color, C for color, or you could even simply say R, that will also work, and this S equal to 20 is the point size, and then plt dot title will add title to the plot, plt dot x label as inside this single quote you write x axis. Here we have written inside dollar because then in that case it will convert x into italic mathematical x. So, this is a LaTeX command for typing X. Similarly, add label to Y axis and then ask it to show. So, let me run this. This is what you get. So, it has added scatter plot as a title. X axis has been given label X axis, Y axis is given label Y axis, and you can see here this X is not usual X, it is somewhat italic. So, if I want to do various things to this graph, we can simply add all these things using PLT. So, you can take help on PLT dot scatter and you can see what are the other options available. Okay. Let me change this point size. So, instead of 20, let us make it 5, then you will get smaller point size, or instead of 20, if I make it 30, you will get larger point size. So, all these things can be done very easily. Next, let us look at how to plot graph of a function f of x, or graph of a function which is explicitly defined in x. So, let us look at, we want to plot graph of a function x into sine x square plus exponential of minus x square by 2 in an interval from -3 to 3. So, how does one plot graphs? So, first you need to generate set of points in the interval -3 to 3, and then for each of these point you evaluate what is the value of the function y, which is equal to f of x. So, if the point is xi, then yi will be f of xi, and then you plot xi, yi, the set of points, and then join them by freehand line drawing. Okay. So, how do we do that? So, first of all, we need to generate the set of points from -3 to 3. So, that we can do using linspace from NumPy library that we have seen already. So, from -3 to 3, let us generate 100 points. Let me make it more points. Suppose we want to, let us say 300 points. So, 300 points, or let me make it 301. That means, it will divide this entire interval from -3 to 3 into 300 equal sub intervals. Therefore, there will be 301 points between -3 and 3 both included. Now, y is equal to x times, since we want for each xi fxi, therefore, you should be using sine and exponential from NumPy, because sine, cosine, etc. exponential functions, this operates on any NumPy array. Okay. So, y is equal to f of x, or is same as saying x into npi dot sine x square plus np into np dot exp minus x square by 2, and then you simply say plt dot plot x comma y, and then ask it to show plt dot show. Okay. So, this is the graph of f x is equal to x into sine x square plus e to the power minus x square by 2. This seems fairly complicated graph. Okay. Next, if you want to do any annotation to this graph, for example, if you want to change the color of this graph, you want to add x axis label, y axis label, or title, or you want to change the style of this plot. For example, we can plot in dotted lines, we can plot in dot 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 lines. All these options are available. So, again you should look at help on plot from PyPlot. That is, since we have imported PyPlot as PLT, you can simply look at help on PLT dot plot, and then go through this help manual and see what are the other options which are available in order to make changes to this graph. So, let us explore some of the options that plot provides. So, first, for example, changing plot style. So, if I want to change the color, we have seen that we can simply say C is equal to red, or simply say R, and then let us say we want to plot change the line width. So, by default the line width will be 1, and if I want to make it line width equal to 2, then you can see this line has become thicker and it has become red color. Suppose I want to make it red but dotted lines. So, then this this will plot. And similarly, if you want, let us say dotted line, you simply say colon, then it will plot as dot dot dot. If you want to plot using plus or using some other symbols, all these there are several options available. So, you can just explore. If I say hyphen and then dot, then it will plot hyphen followed by dot, hyphen followed by dot. Okay, that is what you can see. So, many other things you can explore. Similarly, if you want to add, let us say axis label, let x axis as x axis, y axis. So, you can use x label, y label, and then you can put title to this graph, and then you can also add grid lines using this function plt dot grid, and you can mention what is the color of the grid, line style, what should be the line style, what should be the line width. So, all these options are available. Okay. So, this is what you see. Now, you can see here x label, y label, and this is the title of the graph, and these are the grid lines. Again, grid line also there are several options. You can make these grids finer. You can mention what are the points at which you want grid lines on x axis, on y axis. All these options are available inside pyplot dot plot. Okay. Next, suppose you want to plot multiple graphs together. So, for example, here we have plotted graph of x into sin x square plus e to the power minus x cube. Now, suppose we wanted to plot this as a graph of x into sin x square and another graph as x into e to the power minus x square, and then add these two together. So, that means we want to plot three graphs together. One is for x into sin x square, another one e to the power minus x square by 2, and the third one is f of x, which is sum of these two. So, how do we do that? This is again fairly simple. So, we have already generated set of points x between minus 3 and 3. This we generated 301. So, let us make it 301, and then let me call the first function as y1, which is x into sin x square, y2 as second function, which is e to the power minus x square, and the third function is let us say y3, which is sum of these two functions. I can simply write y1 plus y2. So, let me write that y1 plus y2. So, y1 and y2 are two arrays for each xi. y1 is going to be set of points, which is xi into sine of xi square. Right. Now, when we want to plot all these things together, you can simply again use plt dot plot, and you mention x comma y1, that is the first graph, x comma y2, that is second graph, and x comma y3, which is the third graph. So, let us execute this. When we run this, this is what we get. This is the graph, and you can see this by default it has put graphs in some default color. If you want, you can mention the color here also. Suppose we want to, let us say, add. So, for example, here it has plotted, it does not know which graph is which, right. So, what we can do is we can add legend. So, legend is basically it will add label to each of this graph, and then it will show which color graph is which graph of which function, right. So, again let us generate y1, y2, y3 in the same way as we have done before. First, let us plot a graph of y1 in red color and give a label y1. Similarly, plot graph of y2 and give in blue color and with dash dash dash, and then give this label as y2, and similarly plot graph of y3, and that is in let us put this in green color, and let us give the label y3, and then you simply say plt dot legend empty round brackets, and then ask it to show. It will plot the graphs. Now, you can see here this blue graph is graph of y1, sorry, blue graph is graph of y2, red is graph of y1, and dot dot dot, this is dotted graph is graph of y3, and this legend is written in this place, but you have an option to put it wherever you want, so that you can look at help on plt.legend, and you will see how to place this legend location at various points. Right. Next, let us look at, suppose you want to plot several graphs together, and here we have plotted all of them in the same window, but suppose you want to plot these side by side. Let us say we have 4 graphs and we want to plot first graph, then on the right hand side second graph, below the first graph as graph of third one, and below the second graph of fourth one. That is, you want to plot this in array 2 cross 2 array, or if you have 6 graphs, you can plot in 3 cross 2 array or 2 cross 3 array. So this can also be done. So how do we do that? So that is achieved by what is known as subplot. So first let us look at, suppose we want to plot graph of sine x, and then sine 2x, and then sine 3x and sine 4x in a 2 cross 2 array, 2 by 2 array. So first again let us import pyplot and numpy, though we have already done, so there is no point in importing it again, but in case you are doing it afresh, you should always import these two. And then t, let us, t is a set of points from -6 to 6, and there are 256 points. If you want, you can make it more, and then create a figure of size 6 by 4. Figure of size 6 by 4. You can increase this size, you can make it bigger, you can make it smaller, and then first graph is that is spelling mistake here. So first graph is graph of sine t. So again, so and that how do we add? So in first place, that is at 1 place, you are saying this is 2 cross 2, and then this is the first graph. So it is created 2 by 2 array, and it is adding first inside first let us say box. So it will create a box of 2 by 2 4 boxes of 2 cross 2. The first box will have plot of sine function, and then next we will say in second graph, that is again this here shape subplot 2 comma 2 comma 2, that is the second graph, and this is 2 by 2, and this is graph of sine of 2t in red color, and this is the third graph, which is plt dot subplot 2 comma 2 comma 3, that is the third graph, and so on. And this is the sine 3t, which is in green color, and the next one is the fourth graph, which is plt subplot 2 comma 2 comma 4, and this is sine 4t, and this is plotted in blue color and with dash dash. Okay, so let us plot this. So when you plot this, again you can see here 4 graphs are plotted together. This is sine x, this is sine x square 2x, this is sine 3x, and this is sine 4x. You can have many more graphs together. In fact, it also you can plot inside a plot. Suppose this is a big plot, inside this I want a small plot, that options are also available. So you can go through some of these options. Okay. Next, let us look at how to plot graph of curve which is defined by parametric curves. So x coordinate is some defined as f of t, y coordinate is defined as g of t, and then you want to plot xt comma xt yt from let us say t in some interval a to b. So let us look at, we want to plot a graph of a function whose x coordinate is given by sine t and y coordinate is given by sine t into cos t. Okay. So and we want to plot this graph for t from -4 to 4, and we are dividing this into 200 points. So if you want, you can make it, let us say 400 points. Let me make it 401. So there are 400, this -4 to 4, it is divided into 400 equal intervals, and here a is taken as 2. So a into sine t, so 2 sine t, x coordinate is 2 sine t, y coordinate is 2 sine t into cos t, which is actually sin 2t. So you can simply say sin 2t also, and then you have to simply say PLT dot plot and then PLT dot show. So it earlier also when we have plotted graph of f of x y, actually we did generate x and y coordinates, and then we plotted using plot function inside PLT, right. So this is what you get. This is a graph of parametric curve whose x coordinate is 2 sin t and y coordinate is 2 sin t into cos t, and this is this graph is called figure 8 graph. So that is how. So this is a parametric plot. Okay. Next, let us look at, suppose we want to plot, let us say random walk. So in this case, what we do, suppose we start with from 0 0 and take a random walk, and let us say of unit length. So and then random walk would be in any direction, and then generate the next point. Next point again, in take a random walk from the first point, which is from first point which you have generated, again inside unit circle, inside the unit circle that is of unit length, and keep on doing this, and then let us try to plot all these points and see how it looks like. So again, how do we do that? This is fairly simple. So what we are doing is we are taking, let us say, 1000 points. So again, first of all, you import numpy and pyplot, and there are 1000 points, and starting the coordinate of is 0 0 x comma y comma, and we are this is the radius or the step length by which you are taking a walk. So this is unit step length, and but it will be in any direction. So we will generate a point on a circle of unit length, and then this is the we want to store all these points generated, 1000 points generated in a list. So we have initialized this list as origin, which is 0 comma 0, and then we will keep on adding these points inside P. And how do we do that? So first generate a random angle, right. So this could be between anything between 0 to 2 pi. So generate a random number between 0 to 1 and multiply this by 2 pi. So it will go from 0 to 2 pi, any point between the angle will be from 0 to 2 pi, this will be random, and then generate 2 points x and y. So x point will be you add x plus the r cos theta, r here is L, and y plus r cos theta, y coordinate is y plus r sin theta. So any, you know that any point on a circle of radius r is given by, centered at origin is given by r cos theta, r sin theta, but if it is centered at let us say x y, then the x coordinate will be x plus r cos theta, y coordinate will be y plus r sin theta, and then you append this to P dot append x comma y. So we have generated this 1000 random points, is actually it will be 1001 by starting with origin, and then we want to plot these points. So how do we plot these points? So when you are plotting these points, we have to plot actually a line starting from 0 to first point x1 y1, then from x1 y1 to x2 y2, from x2 y2 to x3 y3, and so on, and this can be again done by using pi dot plot. So we are taking this is the x coordinate of the first point, and then join with these are the set of first coordinates of all the points, these are second coordinate of all these points, and then put in the points are in blue in color. This will be actually it will be plotting a line and blue in color. So let me put that's fine, this is, or let me put green in color, and then you plot the arrow from starting point, that is origin, to the last point, that is the Pn 0 Pn 1. Okay, so that's the arrow. So PLT inside PLT inside pyplot you also have a function called arrow to plot arrow. Now let me run this. Okay, so this is what you get. So we have started with origin here, then it takes 1000 steps, random steps, and this is where it reaches actually, right. So this is we are just making use of all these things in this random walk, right. You can of course suppose if you have generated only set of all the points, if you have plotted just set of all the points in this P, the graph will look like this. So, here one is for x coordinate, this is x coordinate how it varies, and the yellow the orange one is the other one. So, one will be x coordinate, other one will be y coordinate. So, this is some kind of time series plot actually. Okay. Now, you can try to explore. There is also an option to do animation. So, if you want, you can even animate this random walk from Matplotlib. There is a function, there is a library or module called animation. So, you can look at that and then see how we can animate this random walk. Lastly, let us look at one more graph. We have already seen how to approximate pi using Monte Carlo simulation. Now, there we simply generated the points and we counted how many points are there inside unit circle and how many are inside outside this unit circle inside unit square. Of course, we worked with only in first quadrant, but we can also work inside all the coordinates. So, what we will do, we will generate a let me do it step by step. So, first let us import all these things which are necessary, that is numpy, then random function from numpy random, and then pyplot from matplotlib. And then first let us generate a square. So, square or first let us generate a circle. So, circle we want to generate a circle. So, of course, there is a circle function inside the pyplot, but here we have just generated set of points about 361 points, and then all these points are equally placed and then add this inside x coordinate and y coordinate of the circle, and then plot this x coordinate and y coordinate of this circle, and let me see. So, this is a unit circle. Of course, here we have mentioned the figure size to be 5 by 5, that is why you see here a unit circle. In case your figure size is 5 cross 6, you may see this as not as a circle, but as an ellipse, because that is the aspect ratio of the axis. Okay. Next, we can generate similarly a unit square. So, we are writing the first x coordinate of this unit square and y coordinate of this unit square. So, of course, it is 1 minus 1 minus 1 1 1, because you have to start with one point and get back to that particular. So, it is starting at 1 comma 1. Okay. So, let us plot this. This is blue in color. So, this is unit square. Now, inside this we will generate all these points. So, how do we generate these points? So, we want to plot circle inside this unit square and then generate some, let us say 1000 random points between minus 1 and 1, x coordinate and y coordinate lying between minus 1 and 1, and then count which are the points which are inside the circle, which are the points which are outside the circle. So, the point xi yi will be inside the circle if xi square plus yi square is less than equal to 1, otherwise it will be outside the circle. So, in case it is inside the circle, you increase count by 1. So, right. So, what we are doing, we are saying in what are the x coordinate of inside points, y coordinate of inside points, and then outside points, x coordinate, outside point, y coordinates. So, to begin with, these are all empty list, and then inside count how many are inside, 0, and then maximum number of points you want to generate is 1000, and then so what we are doing for each I from in the range max ITR, then you generate x coordinate. So, this is random will generate a random number between 0 and 1, and then subtract 0.5 from this. So, this will lie between minus 0.5 to 0.5, and then multiply by 2. So, that this will lie between minus 1 and 1. Similarly, y coordinate, and r is the calculate r as the distance from the origin of xy, that is x square plus y square square root, and in case r is less than equal to 1, then it lies inside, then you increment the inside count by 1 and append the inside x and inside y as x and y, otherwise you append to the outside x and y coordinates. Okay. And once you have done this, and then let us count how many are inside and how many are outside. So, the ratio of inside count divided by the total number of points and multiply by 4, that is approximately the value of pi. That is quite easy. We looked at this in the last class also, in the previous class. Okay. So, let us generate this. So, in this case, when we have 1000 point, the approximate value is 3.124. Of course, this is a random, so it may vary. So, instead of 1000 point, if I say 10,000 points, then it is 3.11. If I run once more, it may be something else. Okay. So, that is how you can now we want to plot these points also. So, this we did earlier, but now extra thing we can even plot. So, how do we plot this? This is again very easy. So, first you generate a figure size, let us say 5 by 5, plot all these scatter points inside x coordinate of inside points, y coordinate of inside point, let us say green in color, and the point size is let us say 5. Similarly, plot all those points which are outside in blue in color, and plot the square, plot the circle, and then put let us say label, x axis label, y axis label, and then ask it to show. So, that is, so these are the 10,000 points. Green are inside the circle, the blue are outside the circles, and then we are taking the ratio. Of course, you can make a user defined function for this. So, let us see how do we do that. So, we are making a user defined function called pi underscore Monte Carlo simulation of approximating pi, and then by default let us say we choose 10,000 points, and all I have done here is whatever you have generated, all these steps of generating circle, generating unit square, and then generating all these random points, counting how many are inside, how many are outside, and then plot. All these things are put inside this body of the function, and at the end we are also printing what is the approximation of pi. So, that will create. So, if you just look at this particular code, it is nothing but we have just copied all these things inside the body of the function, and you can just, when you run this, now let us call this, I will say pi underscore Monte Carlo. So, by default it will generate 10,000 points, right. So, this is 1000 points, and the approximate value of pi in this case is 3.088. If I increase this, instead of let us say call give a big number. So, this is 1,000,000 points, and it may take little while, but you can see here now you can hardly see the points. Let me reduce the point size, but in this case what is the approximation? Approximation is 3.14. So, correct up to 2 decimal places in this case, and let us say if I have only 10,000 points, this is how it looks like. Okay. So, right. So, you can there are other plots which are available inside the PLT, inside pi plot. So, for example, there is a pi plot dot polar to plot polar graph of polar functions defined in polar coordinates. If you want to plot bar plots, then you can look at pi plot dot bar. Pi plot dot hist will give you histogram plot, pi plot dot pi will give you pie chart plot, pi plot dot box plot will give you box plot. So, those who knows bit of statistics, etc., you can look at all these plots and explore, right. So, it also has option to plot graphs in 3 dimensions, etc., but all these things we will be also doing in Sage Math. There it is much better and much more convenient. Okay. So, at the end let me leave you with a few exercises. First is to plot parametric curve whose x coordinate is given by this, y coordinate is given by this, and t varies between 0 to 2 pi. The next is plot graph of a function which is y is equal to x into sin 3x plus e to the power minus x by 2 along with its derivative in the interval minus 4 to 4. So, you have to calculate the derivative and define the function for derivative. Next is look at this website, which is actually a website which gives you the corona count worldwide. So, from this you can look at the data of first 10 countries with maximum number of COVID patient along with the COVID deaths and make a dictionary out of this data. So, you can go to this website and define a dictionary. Let us call this dictionary as COVID. So, this is the key, and its value can be another dictionary with two fields, two keys. One is the total number of patient and the second one is the number of deaths. And from this dictionary now extract this data and try to plot bar plot of number of deaths of all these countries. You can also plot for example a pie chart of first 5 countries of again by looking at the number of deaths. You can plot the other things, for example density plot and other things, etc. Next problem is again, let us generate a normally distributed points with mean mu and standard deviation sigma using this this command, but we have also seen random dot normal that can also be used. So, generate 100 random numbers which are normally distributed with mean mu and standard deviation sigma and plot its histogram and maybe also density plot. Okay. But there are other actually libraries which can make the Python plot or Python graphics much better. One of them is called Seaborn. So, you can explore Seaborn also. Okay. So, let me stop here. So, thank you very much, and in the next class we should look at another 2 important libraries which are called SciPy and SymPy for scientific computing and also symbolic computing. That again we will look at very briefly, because all these things we will be doing in Sage Math. Thank you very much.